All right, so I got email from several of you that you want me to go over these review problems. That's a great idea. So let me do that with you in the next, maybe like, I'll make like 8 separate videos. Hold on, what can I do? So what I did was I just made a copy of that Google Doc. And because the Google Doc, I just listed the problems. I just added some spaces, like a page per problem, so that I can start going over them with you in several of these videos. So, let me open it. Here it is. One student email, just possible, could you post the work along with the answers on the study guide? I'm having trouble with some of these problems. So he says some of these, and one more person emailed about stuck on 4, 5, 6. So this is what I'm going to do. I'm going to go over number 4 first. Not this one. Problem number 4 first. And then I will come back and go over the other ones too. Today and tomorrow, and hopefully Wednesday too. Sorry with everything going on at the end of the semester. I don't have every day available for my class, for your class. But I'll try to have like at least 1 or 2 done every day. So let me go to number 4. Because I got a question about this one. This is about related rates from 3.9. Remember, we did related rates immediately after we did 3.8 implicit differentiation, didn't we? So implicit differentiation problem is number 38. Because related rates had what? We had more than 2 rates in a single problem. And the one that you did for me was, I think, the saleable price and then the sale price increasing, So you did a problem, but number 4 is a little different. This is about the number of housing starts, H of X, in units of a million over the next 6 years is related to the mortgage rate, M of T, % per year by equation, 12H squared plus 0.75 M equals 51. So we got H and M in here. H is for the number of housing starts in units a million, and M of T. M is for the mortgage rate. So they are related by this equation. That's what we're given. What they want is, what is the rate of change in the number of housing starts? All right, let me go ahead and highlight this for you. The rate of change of the number of housing starts. What are they looking for? They're looking for find DH dt, right? They want you to find DH dt. With respect to time, I guess I better highlight that part too, because that's how I know is dt. When the mortgage rate is 4% per year, so let me go ahead and say M of T. I'll simply just say M is 4%, and it's increasing. Now take a look at the wording though. Mortgage rate is 4%. That's why I have. Let me even color code this with pink pen. I like colors, guys, or red. M equals 4, okay? And that time, it is increasing at the rate of 0.25% per year. So what are we given? We're given a rate here. D, what's the variable? M. dm dt equals how much? 0.25%. So I'm just going to get rid of this percent and just use 4 and 0.25. But it's increasing. If they said decreasing, if your exam says decreasing, you should put a negative in front of it, right? So that's it. M is 4, dm dt is 0.25. I need to find dh dt. All right. Now, how many things do I have labeled so far? The red things, M and dm dt, right? I need to find dh dt. I don't know what h is. So is there a way for us to find what h is? Yeah, of course, we got an equation that relates M and H. So what I'm going to do is I'm going to first find H when M equals 4%. Okay, M equals 4. The mortgage rate is 4. If mortgage rate is 4, what is the number of housing starts? That's going to be 12 times H squared plus 0.75 times 4, M is 4, equals 51. So we're going to solve this for H here. If I do 0.75 times 4, 0.7 times 4 is 3, equals 51. Subtract 3 from both sides, you get 12H squared is equal to 51 minus 3, 48. Divide both sides by 12. Oh, we're getting close. H is equal to, or H squared is equal to 4. And I try very hard to make this number to come out nice. If you take square root of both sides, it's technically positive and negative 2, right? But we're looking at number of housing starts. It's going to be a positive 2. So when the mortgage rate is 4%, the number of housing starts is 2 million. That's what we got. So we're going to use H equals 2 in our equation. Okay? All right. So this was slightly different from the ones that you and I went over together because out of four different variables or four different things, I gave you 3 and asked you to find one unknown. Now this one, we had to find what H is in order for us to plug this in. Now, we need to rewrite this. We need to, differentiate this implicitly so that we can bring in dH dt and dm dt, right? So let me go ahead and write down this equation. 12h squared plus 0.75m equals 51. We're going to differentiate this implicitly with respect to time t, okay? Ready? So let's go ahead and do d dt on both sides. Let me move this 51 over there. By the way, what's the right side going to be? If you differentiate 51, you will get 0. d dt, 51 is going to be just 0. But let's go ahead and differentiate these ones. So each term, what is d dt of 12h squared plus d dt of 0.75m? And the right side is simply 0, right? Now, we are differentiating 12h squared with respect to t. So what we're going to have is first use the extended chain rule. We're going to have 24h to the first power, but multiply this by what? dH dt. We have to use the chain rule and differentiate the inside function h with respect to t. And that is simply going to be dH dt. Plus, all right, let's do the second one. I'm going to have 0.75 m to the 0 power. So that's just going to be that. But don't forget to multiply by the derivative of m with respect to t, which is dm dt, and that equals 0. Now, if you got to this part, we're almost done, right? So we're just going to plug in everything we know. We know that h is 2. 24 times 2 times, we also, no we don't know what dH dt is, so leave that as dH dt. Isn't that what we're looking to find? Yes, that we're trying to find. Plus 0.75 times, but I think we were given dm dt. dm dt is 0.25, and that equals 0. Now, what are we solving for? We're solving for dH dt. So I think when you are doing this related rates problem, as long as you can identify the variable that you're trying to find, what are you trying to find, and label everything else and just plug in after implicitly differentiating the function, you'll be all right. All right, let's go ahead and solve this. So this will be 48 dH dt plus, all right, decimal multiplication. 0.75 times 0.25 is 0.1875 equals 0. Let me subtract that number. 48 times dH dt equals negative 0.1875. And then let me go ahead and divide both sides by 48. dH dt is actually negative. Negative 0.1875 divided by what number? 48. Now, let me go ahead and type this into my calculator. Negative 0.1875 divided by 48. That's going to be negative 0.00390625. Now, why did I write all this number down? Because listen very carefully. What was the unit of H? H was in millions, units of a million. So what I'm going to do is I'm going to multiply this by 1 million. All right, if I multiply this number by 1 million, multiply by 1 million, and you know exactly why I'm multiplying by 1 million, right? This H is in units of a million. This comes out to be negative 3,900 I didn't really type up the rounding rule. I didn't really ask you to round this somehow. So I'll just go ahead and say 0.25. And if you try to write the unit very carefully, what did we find? The number of that's the answer. Let me go ahead and write the sentence answer somewhere over here. The rate of change of the number of housing starts with respect to time is increasing or decreasing? What will you say? Decreasing by 3,906.25 houses per. Now, what was the time unit? Was it years? Yeah, year. Per year. When mortgage rate is 4% and da 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 da. I know you're going to be able to type that up for me. Just describing the answer that we just found. But as long as you tell me that it's decreasing by 3,906.25 houses per year, that's going to be good, right? So this is how you would do number 4. I will be back with a couple more.